Good morning, everyone. I'm Chenagala Sonith Yadav, and this is a Tech Talk. I'm from CSE Data Science, and this is an AAT Tech Talk. And today's topic is the brushing up on maintenance practices of DC motor and DC generator. So let's get started. The aim of this presentation is the successful long-term operation of DC motors and generators. Let's take some parts of these DC motors first. There's the brush, the commutator. The main parts that we'll be focusing today are the brush and the commutator of the motor. The brush touches the commutator as it keeps rotating. The contents for today's presentation are keeping the motor relatively clean, providing good quantity of ventilating air and providing good quality of ventilating air, providing good quality power, keeping vibration to a minimum, maintain a good commutator condition, adjust quantity or grade of brush to be suitable for the application, inspect brushes regularly to obtain a wear history. Do not use silicone sealant to make the motor watertight. Do not over lubricate and remember to remove the grease train plug during re-greasing. Okay, let's get started, shall we? The first topic, keeping the motor clean. Motors dissipate some of their heat through the outside surfaces of the frame. The accumulation of dirt can lessen the efficiency of this process and make the motor operate hotter than it would otherwise. Let's read it again. Motors dissipate some of the heat through their outside surfaces of the frame. Accumulation of dirt can lessen the efficiency of this process and make the motor operate hotter than it would otherwise. Basically, what this statement means is the motors operate with some heat, and motors dissipate heat through their frames from their interiors. And sometimes dirt gets stuck in these frames, and the accumulation of dirt can lessen the efficiency of the motor, and the motor runs with less efficiency. And this would the dirt would get stuck in the outside frame of the motor and leave nowhere for the heat to go through, and the heat would remain inside and make the motor hotter. And this is why the motor would operate hotter than it would normally. Occasionally, blowing out and vacuuming motor interiors are good practices to eliminate dirt and dust, right? So we've established that sometimes dust gets accumulated in the motor's interiors and their outside frames. So the solution for this is we occasionally blow out or vacuum motor interiors through which the dust gets blown out and the motor remains clean. And vacuuming or blowing out are good practices to eliminate dust and dirt. And there are two types of dirt or dust, that is solid or dry, or and liquid or wet dirt slash dust. When the dirt is dry, it should be vacuumed with the use of a soft bristle brush. Right, the normal dirt we use a vacuum, and use a bristle brush to blow slash clean away of all the dry dirt. And for the wet dirt, that is oily dirt, we use a cloth with dampened with solvent. We dip the cloth in a solvent and use it to clean the wet dirt that is accumulated in the interiors of the motor. Avoid flooding or soaking the motor. That is flooding, like what do I mean? Yeah, flooding. You avoid using water during cleaning of motors. That is rushing water through the motor. That is flooding, or dipping the motor in a water body that is soaking. Large motors should be flushed with high velocity, clean and dry airstream to blow out carbon dust and prevent commutator damage. This means vacuums are not enough for large motors. Yeah, vacuums are not enough. So they should be flushed with high velocity, clean and dry airstream to blow out carbon dust and prevent commutator damage. Large motors have a amount of carbon dust accumulated in them, and due to this, the commutators often get damaged. Uh, when we flush them with high velocity, clean and uh, dry airstream, all the dust is blown away, and this prevents carbon dust from accumulating and prevents commutator damage. The next point is commutators can also benefit from blowing out particles that have lodged in the undercut area between individual commutator bars. This process is called air curing and involves direct, clean, pressurized air towards the commutator as it revolves. Let's read it again. Commutators can also benefit from blowing out particles that have lodged in the undercut area between individual commutator bars. The process is called air curing and involves direct, clean, pressurized air towards the commutator as it revolves. So this is a commutator, right? Commutators, there is a dust lodged in these undercut areas between individual commutator bars. So this is one bar and this is another bar. In the in the undercut area between both the bars, there lies dirt particles, and we need to blow out these particles with we need to blow out these particles with high speed air. This process is known as air curing and involves direct, clean, pressurized air towards the commutator as it revolves. So the next point is providing good quantity of ventilating air. Recently manufactured motors would require much more ventilating air than those with the same rating made a few years ago. So, what the first point means is the new motors need to function at full capacity. So, full capacity, you need a large quantity of ventilating air. So, the older ones, which are used to functioning with optimum ventilating air are cool, but the newer ones need a large amount of ventilating air to operate at full capacity, as they are newer ones and uh, need to be used at full capacity. Motors that are force ventilated have their air requirements listed on the motor nameplate in cubic feet per meter and inches of water pressure. Motor, yeah. Sometimes you force ventilate some motors. They have their air requirements listed on the motor nameplate in cubic feet per meter and inches of water pressure. So the OEM or the original equipment manufacturer makes the nameplate for these motors, which specifies the air requirements, which are listed in cubic feet per meter and inches of water pressure. These are the minimum values for the proper volume of air and pressure required to force that much air through the motor. So these are the minimum values through which, for the proper volume of air and the pressure required to force that much air through the motor. These are the minimum values for which your motor will operate. Next, we go on to provide good quality power. Most motors are operated on adjustable voltage silicon controlled rectifier supplies, that is SCR power supplies, which have become quite reliable in the past few years. Before this is an article from 2001. So SCRs were new then and were quite reliable in the past few years, have become reliable in the 1990s. Before that, power supplies were not as reliable and would usually fault. So the SCR power supplies, which came in the late 1990s, are SCR power supplies, which have come in the 1990s, have become quite reliable and do not falter that easily. The common types of SCR power supplies are usually identified by letter codes A, C, D, E, and K. So the nameplate on the bottom of the motor also tells us the power rating of the motor, with the lower letters in the alphabet having the lower magnitudes of ripple current. This means a motor rated and designed for a D power supply could be used with a C power supply, but not an E. So the higher the letter, so the earlier the letter, the more power rating the earlier the letter, the more power rating it has. Like, they give an example here. That is, yeah, a motor rated and designed for a D power supply could be used with a C power supply, but not an E. Right. Let's take an example of our own. Let's take E power. No, D power supply. Nahin, let's take an E power supply. It can be used with a D power supply, but it cannot be used with a K power supply. That means it can be used with a higher power supply, but it can never be used with a lower power supply. SCR power supplies are quite reliable, but do occasionally fail. This causes unbalanced or totally missing pulses during operation that increase the amount of current ripple and could be the cause of increased motor sparking. SCR power supplies are reliable, but they're not perfect, and sometimes they fail too. This causes unbalanced or totally missing pulses during operation. When SCR power supplies fail, the power in yeah, the power in the motor fluctuates. It fluctuates between higher and lower points, which is not balanced, and this causes totally missing pulses during operation of the motor, and this causes current ripple, which could cause motor sparking. Like this, when the motor works, there will be sparks, and this is not good for the wear and tear. This is not good for the health of the motor, and the sparks cause more wear and tear. On to the next topic, keeping the vibration to a minimum. Most new motors generally have less than 0.0015 inches of vibration for the motor itself as required by the National Electric Manufacturing Association NEMA. Let's read it again. Most new motors generally have less than 0.0015 inches of vibration for the motor itself as required by the National Electric Manufacturing Association. So new motors have less than 0.015 inches of vibration for the motor itself, and this is standardized by NEMA, that is National Electric Manufacturing Association. The next point: once the motor is mounted and coupled to the driven equipment, vibration for machines operating at less than 2000 Once the motor is mounted and coupled to the driven equipment, operating vibration for machines operating at less than 2000 rpm should be limited to 0.02 inches of displacement or 0.08 inches per second velocity for long-term trouble-free operation. Let's see it again. Once the motor is mounted and coupled to the driven equipment, operating vibrations for machine operating at less than 2000 rpm should be limited to 0.02 inches of displacement or 0.08 inches per second in velocity for long-term trouble-free operation. Minimal commutator runout. Brush life depends on commutator surface being smooth and true as possible. This ensures good contact can be maintained between the brush and the commutator. When a commutator surface is excessively rough and brushes start to bounce, sparking current being conducted through the air occurs. This damaging arcing process continues with each revolution. Let's read it again for clarity. Brush life depends on the commutator surface being as smooth and true as possible. This ensures good contact can be maintained between the brush and the commutator. When the commutator surface is excessively rough and brushes start to bounce, sparking occurs. This damages our arcing process continuing with each revolution. So, the brush life depends on the commutator surface. When the commutator surface is smooth and true, the this ensures good contact is maintained with brush and commutator. When it is rough, the contact is not very good and it causes ripples of current, which is also known as sparking. As we established earlier, sparking and current ripples are not good for the health of the motor and could cause severe wear and tear. A typical commutator could possibly last more than 20 years if properly maintained, right? If the surface of a commutator is maintained smooth and true without it getting rough, it could last more than 20 years. It could last more than 20 years easily. The next one, number and grade of brush suitable for the application. The quantity, grade, and size of brush chosen by the motor manufacturer are based on the nameplate rating. In the case of a 200 HP motor rated for continuous duty, the OEM, that is the original equipment manufacturer, selects brushes by figuring that this motor is to be used at or near the full load nameplate rating. So let's read again. The quantity, grade, and size of brush chosen by the motor manufacturer are based on the nameplate rating. In case of a 200 HP motor rated for continuous duty, the OEM, original equipment manufacturer, selected brushes by figuring that this motor is to be used at or near the full load nameplate rating. We get it. Unfortunately, many motors once installed and running in their application are operating far below their nameplate rating. Like when you buy a new motor, they most of when you buy a new motor, you expect it to run at full capacity, but many of them do not reach their full capacity once installed and when they are running and are operating far below their nameplate rating. That is written by the original equipment manufacturer. The most common brush grades used today for industrial size motors are electrographitics. In general, that is EG. In general, most EGs have maximum current density of about 80 amps per square inch. However, they all have a preferred operating range, usually in the range of 40 to 80 amps. Brushes need to be replaced when the spring has run out of travel and no longer sufficiently pushes the brush towards the commutator surface. So brushes and the springs are in contact. This is a commutator and this is a brush. And the springs that are used on the brushes elongate the brush and which causes contact between the brush and the commutator. When the springs wear out, the brush no longer reaches the commutator. In this case, the brush needs to be replaced. Many original equipment motor manufacturers list the minimum brush length in instruction book or maintenance manual that comes with the motor. Brushes need to be replaced if past history shows that the minimum brush length will arrive before the next scheduled shutdown or maintenance inspection. The summary. Visually inspecting and recording the information as suggested will serve well to diagnose motor problems or a certain good operating health of the DC motors. So the summary is all of the points that I told. If we follow those, your the DC motor will run in good health, and these points will help us identify any problems with its health. This is my source. This is an IEEE publication. This is a 2001 article by Gary E. Lazowski. Thank you, and that's it.